Welcome to my video on determining how much electrical power this takes to run this little simple electric heater, and then how much it costs me per day. I've got my PN 1500 watt meter. I just plug it into the wall, and basically plug that into the watt meter, and it tells me all kinds of information about what I've got, how much power I'm using. Now it's on the watt scale. You see the little W right there, so it's pulling 0 watts right now. This is just your generic fan heater. It's got a fan setting, and that just as a fan. Then these are the 2 heat settings. And I've got it set on the maximum power requirement. The little arrows right there. So each of these settings I want to go through and see how much power it's taking. All right, so first thing I'm going to just put in the fan setting. Okay, that just blows air. It's not really hot or anything. And it looks like it's about 3.14 watts. So it doesn't take a lot of power just to run the fan. Now I'm going to switch it to the first setting. It's got a device that allows it when it gets turned up to turn off. I'll put it on the first heat setting. So it looks like now it's pulling. It'll stabilize in just a second. The wattage requirements are changing because the heating elements change. Their effective resistance changes. So we have to give it a second to stabilize. So we get a long-term number. It looks like it's around 6. I'm going to go with 703 watts. What I'm going to go with. Okay, now I'm going to turn the highest heat setting to. You'll see the wattage changing. We're pulling more watts, and it's going to take it a second to stabilize because the heating elements are getting hotter and they're introducing more resistance. Okay, so we're going to go with 1290 watts approximately for the amount of power that it's pulling at the number 2 setting. So now let's do some calculations. In this part of the video, I'm going to go through and do the energy calculations for the measurements we just took on the electric heater. So here's the energy calculations. So what I'm going to do in this part, 2 basic equations we have is the energy that's measured in kilowatt hours is equal to the power, which we just measured, and that's in kilowatts, times the amount of time. That's going to be measured in hours. So there's our first equation. It calculates the amount of energy. And our second equation is the cost factor. So the cost is the energy measured again in kilowatt hours times the price per kilowatt hours. And in this case, I pay about 15 cents per hour. Well, it's actually per kilowatt hour. That's my energy cost, 15 cents per kilowatt hour where I live. So the first thing we want to do is we want to convert watts to kilowatts. So that's going to be simple. We're going to just divide by 1,000. So let's look at the fan setting. We had 3.14 watts. Divide by 1,000. That gives us 0.00314, and that is going to be in kilowatts because there's 1,000 watts per 1 kilowatt. So in the heater setting number 1, we use 703 watts. Divide by 1,000, we get 1,703, and that's going to be kilowatts. So not quite a full kilowatt is the power rate on that. And in the 2 setting, we use 1,290 watts with the power. So that's 1.29 kilowatts. So there we've converted to the proper units we're going to need in kilowatts up here for our power. Now, let's go through the second step we want to do is we want to do the energy usage per hour. So the fan, and so all we're doing is here multiplying by the time. So it's really, the numbers aren't going to change, just the units. So on the fan, we've got 0.3314. Now it's kilowatt hours because we multiplied in just 1 hour. So that's multiplied by 1, but the units changed. So the heater is going to be 0.703 kilowatt hours. And in 2, we have got 1.29 kilowatt hours. So now we're dealing with the energy usage. Here it was the kilowatt hours. See, it's got the same numerical value, but the units have changed. Now we're measuring the energy. So now let's do the hourly cost. So in the fan, so now we're using the second equation right here. So we've got 0.00314 times, then we got 15 cents per hour, that is per kilowatt hour, which is going to be equal to 0.00047 dollars per hour. And that's roughly 0.05 cents per hour. So the fan doesn't cost us much to run. That's just a little fan, it's small, it doesn't require a lot of power. Now, if we put the heater in the first stage, it's 0.073, and that's times the 15 cents per kilowatt hour, and that's going to give us 0.105 dollars per hour. Just multiplying that out, which is approximately equal to 10.5, that's cents per hour. So it costs us about a dime to run the heater in the stage 1 for an hour. Now if we go to stage 2, requires more. It's 1290 watts. So that's 1.290, and that's going to be kilowatt hours times the cost per kilowatt hour. That's going to be $0.1935 per hour, or approximately 19.4 cents per hour. So it costs us about 20 cents to run the heater for an hour. Now, if we want to do let's calculate what it costs to run this in the stage 2 heater for 24 hours. So now we have got this 0.194, I just rounded that. That is going to be dollars per hour times 24 hours. That's going to be equal to $4.65 per hour. Now that's per 24 hours, that's per day. So that's our daily cost. And you can see that's rather expensive because that's just a small heater that would basically heat a small room. So if you had several of these in your house, it's going to cost you $20, $30 a day to heat your house. So it's not a very cost-effective way to heat a house with a small space heater. Well, I hope you learned something about the calculation on this and approximately what a small space heater costs to run every day. And I want to thank you for watching.